Hey guys, today I'm going to talk about the area of a circle. Well, we all know that the area of a circle is pi r square. But have you ever wondered how we came up with this formula? Where does the pi come in from? Right? If you take the other shapes such as rectangle, um, the area calculation is pretty straightforward. So it's simply length into breadth, right? Um, and so on for other shapes. But for the circle, we just know that it's pi r square, but we kind of don't know how we came up with pi r square. So today let's do that. Today let's try to derive the formula for the circle as pi r square, right? So I'm going to assume that you already have the basic fundamental knowledge of trigonometry, integral calculus, and analytical geometry for this, right? So let's actually draw a circle. Well, before we draw a circle, let me draw a small, actually a little bigger, a 2D graph, right? We all know what a 2D graph is. This is the x-axis. This is our y-axis. This is our point 0, 0, which is the beginning, the, you know. So if I go and draw a circle over here, the circle, you can see, cuts all the four axes at radius r, right? So this is point r comma 0. This is 0 comma r. I changed the r here. Let me make it the same. Okay. And this is 0 comma 0. So this is our radius r. This is also our radius r, right? And so all we need to do basically now is try to find out the area of one sector, like one segment. Like if I could find the area of this guy, I could just multiply that by 4 and find the area of the entire circle, right? So let's try to use integral calculus to actually find out the area of this particular part, right? So what I'm going to do is I'm going to draw another line, from here, and this is also radius because it's the same thing, right? And then what I'm going to do is I'm going to draw one line which is exactly parallel to this y-axis, and it meets the x-axis at this point. And let's just say this is y, right? And this is x. I hope you can see this. Let me take this off. So this is x, this distance is x, this distance is y, and we know this distance is r, right? Now, if you remember the Pythagoras theorem, this is a right angle triangle, right? So according to Pythagoras theorem, the square of x plus the square of y gives you the square of r, right? So let me write it down. So square of x plus square of y is equal to the square of r, right? This is our Pythagoras theorem, right? So now what we need to do is basically find out the area of this particular segment, and to do that I'm going to choose the y coordinate, right? You could also choose the x coordinate, but I'm going to choose the y coordinate. So what I mean by doing that is I'm going to represent y as a function of x. You could also do the reverse by saying x as a function of y, but I'm going to do is y, right? So if I have to take y and express that as a function of x, how can I do that? Well, I have y over here, right? So what I can do is I can rearrange this particular equation in a way such that y is a function of x. So what I'm going to do is I'm going to bring the x on the other side, so which makes y equal to r square minus x square, right? And then y can also be written as square root of r square minus x square, right? So this is our f of x, right? F of x. Now we're going to attempt to find the area by integrating this. So all we need to do is integrate this. And what are our limits? Our limits are basically 0 from here to this distance. This is the boundary of a circle, right? So which is r. So our limits are going to be 0 and r. All right. And obviously dx, because we are integrating it with respect to x. So dx. Now the challenge for us is to find a solution for this guy. And if we can find a solution for this particular equation, we have the area of this particular sector, and then all we need to do is just multiply this by 4 and you get the area of a circle. So let's actually attempt to find the area, or to find the solution of this particular problem. Now having a square root in the integral definitely gives us some complication over here. So what I'm going to do is I'm going to kind of try to substitute some values over here and probably do some kind of a transform, right? So let's see how we can do that. So what I'm going to do is I'm going to redraw this part a little bigger so you guys can understand it better, right? So this is just the one segment, this guy over here, right? So this is r, and I'm going to draw the same thing over here. This is y, this is x, so right angle triangle, and this is r. Now what I'm going to do in this is I'm going to denote the angle as theta. All right, so I'm going to denote the angle as theta. Now let me just draw. Okay, alrighty. So now we have the y, we have x, and we have r. How about we try to represent x, y, and r in terms of sine and cosine, right? So what is basically so this is the opposite side, right? This is the opposite side, this is the adjacent side, and this is our hypotenuse, right? So opposite side divided by the hypotenuse gives us the sine theta, right? So we can say sine of theta is equal to opposite side divided by the hypotenuse, which is basically y divided by r, right? We know what y is. Y is nothing but square root of r square minus x square, right? Before we applied the integral. So what we could say is sine of theta equal to r square minus x square by r. And if we just cross multiply this, we get r square minus x square is equal to r sine of theta, correct? So let's just keep this as it is. Now what is this? This is the adjacent side, right? And if we try to represent x and r in terms of sine or cosine, we probably are looking at cos theta, which is basically x divided by r. So x divided by r, or you could say x is equal to r cos theta. I'm sorry, I'm using different versions of r, but they're the same thing. So you know, so x is equal to r cos theta, which is correct because x is r into the cosine of theta, right? If x is r cos theta, if I differentiate it on both sides, we get dx by d theta is equal to r is a constant, so r remains as such, and differentiation of cos theta is nothing but sine theta, so we get r of sine theta, right? Now from this, what is dx? Dx is nothing but r sine theta into d theta. All right, now let me circle this and this, right? Now we take these two guys and we put that in this equation. So what do we get? Integration of this is equal to r sine theta, so r sine theta multiplied by dx, which is dx, so multiplied by r sine theta d theta, right? So now if you see what I was talking about earlier of applying a kind of a transform to this guy, so we have kind of transformed from the x coordinate system to the theta coordinate system, right? The angular coordinate system. So accordingly, our limits are also going to change. Now we were earlier going from 0 to r, but now our limits are going to be from angle 0 to angle 90 degree, which is basically pi divided by 2, right? Pi. So if you go back to the circle, this particular angle is 0, you know, this is pi by 2, this is pi, this is 3 pi by 2, and this is 0 again, right? So this is how the angle goes around in a circle. So we are only concerned with this particular sector, right? So our angular limits are going to be 0 to pi by 2, right? So 0 to pi by 2. Now this, if you simplify, try to simplify this, we get 0 to pi by 2 r square dot sine square of theta. All right, I forgot the d theta, right? So let me actually show you on a page. So we had 0 to pi by 2 of r square into sine square theta d theta. Now from the trigonometry formulas, we know that sine square theta is equal to 1 by 2 minus cos 2 d theta by 2. This is a standard trigonometry formula, you can look it up. So what I'm going to do is I'm going to substitute this guy over here. We know that r is a constant, so we might as well bring it outside. So r square of limits 0 to pi by 2 of 1 by 2 minus cos 2 theta by 2 multiplied by d theta, right? Now we can split this integral into 2, so r square remains outside, and we can split this into 2 integrals, which is 1 by 2 d theta minus integral of 0 to pi by 2 um, cos 2 theta. And what I'm going to do is I'm going to take this 1 by 2 outside, right? Because it's a constant, so I can take it outside. I can take this guy outside as well. So 1 by 2 here, and just d theta. And this is cos theta, d theta, right? So integration of d theta is just theta. So this becomes 1 by 2 into theta, limits of 0 to pi by 2, minus 1 by 2. Integration of cos 2 theta is nothing but sine 2 theta plus c, some constant, right? And this is 0 to pi by 2. All right. So now, what is this? This is equal to 1 by 2 into pi by 2 minus upper limit minus the lower limit. So, and minus 1 by 2 sine 2 pi by 2 plus c minus sine 0 plus c, right? So sine pi is 0, right? Sine 0 is also 0, and this c just cancels with this c, right? C minus of minus c is basically 0. So this entire thing is basically 0, right? So we get r square into pi by 2 minus 0 is pi by 2, so pi by 2 into this is pi by 4, right? And minus 1 by 2 into 0. This gives us pi r square by 4. Now, this is the solution to this, right? As I said, if we find the solution to this, we have found the area of one sector. And to find the area of the circle, we just multiply the result of this by 4. So if we multiply this by 4, you get pi r square, which is the area of the circle. Phew. Right, so here we go. We have derived the formula to calculate the area of a circle, which is pi r square. All right, please do leave a comment and let me know if this helped you. Thank you.